Going on to another topic in Chapter 1, Section 10, Subtraction with Integers. And you might say, well, didn't we do subtraction already? Well, there is, of course, the connection between positive and negative numbers when we add them. When they're unlike signs, it's sort of like subtraction. But we want to review these topics. I don't have to read them aloud. You can take a moment, look them over, similar to what we did for addition. And again, additive inverse is in subtraction as well. If you have a negative value, its additive inverse would be the opposite positive value. Now, one of the things we often note, too, that here you see A minus B. This is subtraction. Now, another way to write that is A plus a negative B. This is addition. So you see there is a lot of connection between addition and subtraction when we're thinking of signed numbers. Okay, well, let's work these out here. Instead of just looking at the answers, let's just work a few of them here. So, again, the opposite of a negative will make this positive here. And then this becomes 4. The opposite of a negative makes this positive, and this becomes 5. Now here, we're going to take the opposite of a positive 3. Now that's going to make that a negative 3. You can make this a positive now. And this becomes this is a negative 10, negative 3, negative 13. Again, this is the opposite of a 5. We can make that negative, make this positive. This will be a negative 1. And then the opposite of a negative makes this a positive. So this would be 0. Again, we're looking for that intuitive sense. What's going on? Are the signs correct? And let's do these. So again, we could do some changing of signs, or we could leave it the way it is. So this is a negative 18. This is a 5. So the absolute value of a negative 18 would be 18 minus 5 would be a 13. But then we apply the sign of the larger absolute value, negative 13. Now here, both of these are negatives, so we in a sense could stick in a little positive if we wanted. And this would be a negative 23. Again, we could stick in a little positive there. This would be a negative 19. Now this is as close to the normal subtraction as we can get. This is a 5. Now again, you could take the absolute value of this, subtract that, you're going to get a 1 is a difference, and use the sign of the larger absolute value, which is negative. So again, if you know these, fine. Again, you might run into them as a quiz question on our flipped classroom review. Now in this one, this is negative, and we're subtracting then a positive. So theoretically, the opposite of this makes this a negative 32. So a negative 32 and a negative 45, there's the sign change, gives you a negative 77. Again, the concept of subtracting. Subtracting something, take the opposite sign of this and then just add them. So the opposite sign is a negative 10 now, and that becomes a negative 66. Now, notice what's happening here. The top is negative. The opposite of a negative makes this a positive. So our larger value now will have a positive sign. Subtract the 20 from the 95 and get 75. Okay, a few of these now. Determine whether or not the given integer is a solution. If we put a negative 14 here, negative 14, now notice this becomes a plus 6. That's going to be a negative 8, and they do not equal each other, as we see here. So it's not a solution. Here we're going to put an 8 there, a negative 8 and a positive 1. That looks good. Then you want a technique for doing it, writing them out in a clear and reasonable sequential way to arrive at your solution. Putting a negative 10 there, a negative 10 and a negative 12, so negative 22, so this is not going to be true. Okay, this was a short one also.